Hello and welcome to the Emotion and Theme Recognition in Music using Jamendo task overview presentation. My name is Tovstogan and I am from the Music Technology Group, Universitat Pompeu Fabra in Barcelona, Spain. So, music emotion recognition is not a new thing in the music information retrieval. It had actually been conducted in the context of MediaEval before, but it was focusing more on the arousal valence annotations. Also, audio mood classification had been a task in the MyRecs since 2007. But one thing that had not been explored enough is the theme recognition, the things that these tags like epic, dark, or Christmas. The data that we are using is coming from the Jamendo.com, the provider of the royalty-free music for the commercial use. They have a lot of annotations for the themes and moods, but also for the genres and instruments. The dataset had been presented in the ICML 2019. It is called the MTG-Jamendo Dataset, which consists basically from the music from the Jamendo with their annotations. In total, 55,000 of the tracks, but for the context of this task, as we are only focusing on the moods and themes, it's a bit more than 18,000 tracks. And all of the audio is under Creative Commons license, and it is curated by the Jamendo, not only the audio quality, but also the tag quality. But we are focusing on the moods and themes subset for this task. Total it has 56 tags, as you can see all of them here on the bottom. And as you see, like, it's quite unbalanced, but it's one of the challenges of this task. And there have been 224 tags before we have filtered out the less used tags so we said like the tag needs to be used at least by 50 different artists, and there are some quite interesting tags, but definitely would be quite difficult to predict them. And you might be asking, what is the difference between mood and theme in the context of this task? And we don't distinguish between them. They are both related as just tags that need to be predicted, although some of the teams actually tried to separate them into these categories. So the goal, as we mentioned, is to automatically recognize the emotions and themes conveyed in a music recording using machine learning algorithms. And when we introduced this task in the previous year, in 2019, the concept of the themes was the new thing of the tags, and we have introduced this new dataset, MTG-Jamendo Dataset, and as we mentioned before, the audio is available under the Creative Commons license. Let's see if actually humans are good at recognizing the emotion and mood tags, because it is actually not as trivial as you might think. So I'll play 3 examples and try to think about which emotions, moods, or themes tags would you assign to them. So the first example. So it is tagged as melancholic, melodic, and sad in our dataset, which kind of makes sense. The second example. This one is much more difficult. So it is tagged as documentary, emotional, and space, which this one definitely makes sense. And the third and last example. So yeah, this one is tagged as commercial, corporate, happy, and motivational, which definitely could be used as the music in some of the corporate videos. So as you see, those are not as trivial as you might think. So just like going again with the data, in total we have more than 18,000 tracks with 56 tags. And we provide the MP3 files, or we also have an option of the already pre-computed smell spectrograms in the NumPy format. And we also provide some of the features that are extracted with the Essentia library, such as you can see here like key, BPM, and other features. All the tracks are of the duration at least of 30 seconds, and we have merged a lot of similar tags like emotion and emotional, and each tag is used at least by 50 different artists. So we ask our participants to provide us the tag activation values for the test partition of the dataset that is available. And optionally also with some of the predictions like 0 or 1 if they think that this tag should be predicted or not. We used ROC-AUC and PR-AUC as the main evaluation metrics with the focus on the PR-AUC, and also F-score, which is the combination of the precision and recall for the optional predictions. Just going very briefly through our baseline, we used 5 convolutional layers with the dense layer in the end with the 56 output tags, and the performance is 0.107 of the PR-AUC and 0.725 for the ROC-AUC. Looking at the solutions that we have been receiving this year, in total we have received 21 run by 6 teams, and all the submissions are deep learning architectures. And here you can see the word cloud of the titles of the submissions, removing the task name. And comparing to the previous year, attention is much more popular right now. And spec augment, data augmentation method also is very common used by a lot of participants, basically to try to increase the amount of the data, because 55,000 is actually not that much for the modern deep neural networks. And we had seen some ensembles in the 2019, but right now almost every submission is using the late fusion to combine several of their architectures to obtain better performance. So here is the leaderboard of the best runs per team, and you see as most of the teams have surpassed our baseline, and you can see the approaches that have been using and external datasets like MSD or Music for All or NSynth. But I'm sure that our participants would be giving much more details in their individual presentations. Good news is that we have improved over the previous year. The best submission of the 2019 and the best submission of 2020, the performance is a bit higher. It's not by a lot, and we didn't conduct any statistical significance testing, but it's good news. But the question still remains, is it about having more data versus having better approach? And as 55,000 tracks is generally not a huge amount for training of the neural nets, our data augmentation is very common in the submissions. And interesting to see that the winning team, they were focusing on the different loss functions, and all of those loss functions are actually good for the unbalanced tags as we have in this dataset. One of our teams, like Augment, they were focusing on trying to achieving the same performance with much smaller models, which is quite important right now with the deep learning contributing very much to CO2 emissions. So we are considering to do the same task in 2021, but some of the things that can be addressed are either introducing more datasets or doing something about the tag balance, maybe individual tags, or more metadata to be incorporated, like genre or instruments. Talking about reproducibility, everything is in open. The code is on the GitHub, and all of the audio is available under Creative Commons. And 4 out of our 6 teams have already published their source code on the GitHub. And if you go to this URL, you will go to the task page and you can see all of the details. So thank you very much.